Now, number 3, okay, is another proof that could have been done in more than one way. Okay, again, since this was hypotenuse leg, I said specifically to use hypotenuse leg in this case. Okay, so I'm going to write it using hypotenuse leg. Then we're going to talk about the other methods. Okay, so I'm going to mark the diagram first. QS is perpendicular to PR, and so that's going to make both of those right angles. Okay, QS, of course, is congruent to itself by reflexive. Okay, but this is P and R are congruent. Okay, so right away we've got angle, angle, side. We could do this one with angle, angle, side right off the bat and be done. Okay, but to use hypotenuse leg, that's going to allow me to talk about one other property of triangles that we've talked about before that will allow you to get each of the two hypotenuses congruent to each other. Okay, since I got angle P and angle R congruent to each other, triangle QPR, the big triangle, is isosceles, meaning that these two sides opposite those congruent angles are congruent to each other. Okay, so QP is congruent to QR, and the reason will be the side in a triangle, the sides opposite congruent angles are congruent. We saw that a couple of times in the helpful hints ditto. Okay, so I'm going to write it that way because you need to be aware of that, reason, aware of that concept, because it will show up in other proofs. Okay, like I said, in this case, you could have done angle, angle, side and been done, but to do hypotenuse leg, you need to use this particular triangle concept. So I'm going to write it that way. Okay, so here we go. All right, so 1, I'm going to say QS is perpendicular to PR. Okay. Okay, that's going to tell me 2, angle QSP is congruent to, is a right angle, QSP, and I don't care that they're congruent for hypotenuse leg, I just care that they're right angles. Okay, angle QSP and QSR are right angles. Okay, that is 1. Definition of perpendicular. Okay. 3, that's going to make triangle PQS and triangle RQS right triangles. Definition of right triangle. Triangle with a right angle in it. Okay. 4. Let's see. QS, I'm going to just say QS is congruent to itself. Okay. 4, that is by the reflexive postulate. Okay. 5, I'm going to say angle P is congruent to angle R. Given. Okay. Now here is where we're going to use that special triangle concept. In triangle PQR, that singular triangle, PQR, the big one, if I've got two angles congruent to each other, the sides opposite those congruent angles are congruent. So I can say PQ is congruent to QR. Okay, and this is how that reason would have to be stated. 6. In a triangle, the sides opposite congruent angles are congruent. Okay, the sides opposite congruent angles are congruent. Okay, and now those are my two hypotenuses. Okay, so now 7, I'm finished basically. Triangle PQS congruent to triangle RQS, and we showed that using HL congruent to HL. All right, so that's it. Again, that one could have been done more than one way. Okay, I wanted to show you this particular idea of in a singular triangle, PQR, if you've got two congruent angles, P and R, the sides opposite those congruent angles are congruent. So that is another concept we haven't seen in any of the other practice proofs. Okay, so that's why I wanted to do this one using hypotenuse leg, knowing clearly you could have done it using angle, angle, side. Okay, so that's it. All right, talk to you all later.